Hi, my name is Curtis, and my group members are Riley, Catherine, and Rainey. Our topic is exploring bivariate data 2, and the topic we're going to be going over today are reading computer outputs, forming a least squares regression line from that data, learning about residual plots and residuals, and interpreting the slope, y-intercept, and residual from a least squares regression line. Let's get into it. Here is an example of what a computer output looks like. Now, let's break it down. From a computer output, you can pull the y-intercept, slope, and standard error of that slope, t or z values, p values for significant test, standard deviation, and r squared. So these are the steps for how to use a TI-84. So first, you turn on the calculator, you press the stat button, and click edit button under the edit tab. Enter in all the x values under L1, enter in all the corresponding y values under L2. Press stat button again, go 2 tabs to the right and press the tab button. Go all the way to the bottom and select line reg t-test. Select L1 for x-list, L2 for y-list, 1 for frequency, and not 0, greater than 0, or less than 0 based on what the alternate hypothesis is. Press calculate. A screen should come up displaying all the values that should be needed. Using the computer output data from a calculator, you can then make a least squares regression line. The least squares regression line is the line that makes the sum of the squares of the vertical distances of the data points from the line as small as possible. Don't confuse this with the regression line, which is a straight line that describes how a response variable y changes as an explanatory variable x changes. The format of the least squares regression line is y hat equals a plus bx, where y hat is a predicted response variable and x is the explanatory variable. From the computer output, the a is the y-intercept and b is slope. Take your slope and y-intercept and plug it into the equation. This is your least squares regression line. Always remember to put a hat symbol on top of your y to indicate that it is the predicted value. Otherwise, points will be taken off. Also, when creating your least squares regression line, make sure you know how to define any variables you use in context. Here's a set of data. Pause the video and using your TI-84, find the least squares regression line. You should also know how to interpret certain variables of the least squares regression line, such as the slope and y-intercept. The general format of interpreting the slope is, for every 1 unit increase in the explanatory variable, our model predicts an average increase or decrease of blank in the response variable. For the y-intercept, it would be, at an explanatory variable of 0 units, our model predicts a blank in response variable. Pause the video and interpret the y-intercept and slope in the context of this problem. So the slope would be interpreted as, for every 1 milligram increase in caffeine content, our model predicts an average increase of 0.164 in pulse rate. The y-intercept would be interpreted as a caffeine content of 0 milligram. Our model predicts a pulse rate of 2.544. So here's an example problem. This is from the 2016 FRQ number 6B. For this problem, the slope of the least squares regression line is 1.1594. This means that for every additional semester, the predicted starting salary increases by $1,159.40. The last topic we'll cover is residuals and residual plots. What is a residual? In regression analysis, the difference between the observed value of the dependent variable y and the predicted value y hat is called the residual. So basically, residual is y hat predicted minus y actual. So how do we interpret a residual or a residual plot? When you look at a residual plot, we can determine if a linear model is appropriate for modeling the relationship between two variables. When there is a leftover pattern or scattered pattern, a linear model is appropriate. However, when there is a distinct curve or pattern on the residual plot, it indicates that a linear model is not appropriate. For example, this residual plot has a distinct curve to it, indicating that a linear model would not be appropriate. There is a leftover pattern, random scatter in the residual plot below, so a linear model would be appropriate. Each residual plot has a line that goes through the plot at residual equals 0, allowing us to be able to tell whether the predicted value was higher or lower than the observed value. Additionally, when the residual is negative, it indicates that the data points are below the regression line. When positive, the data points are above the regression line. Another example is from the 2014 FRQ number 6A. That's basically all there is to our topic. There are many resources you can access in order to get more practice on this concept, such as Khan Academy. Make sure to look back at the FRQs we referenced for further practice. Thank you.